So coming to the first question, the name of the question is a knockout tournament. So a knockout tournament is a type of elimination tournament where the loser of each matchup is immediately eliminated from the tournament. The following image showcases a knockout tournament between 16 players. So like you can see, you have 16 players, P1 and P2 played, P1 won, and P2 is eliminated there itself. Similarly, P3, P4 played, P3 won, P4 is eliminated there itself. Then again over here, P1 and P3 played, P3 won, P1 won, and P3 is eliminated there itself, and something like this is happening. The person when loses gets eliminated right at that point of time. This is what we mean by knockout tournament, isn't it? So you are given a tournament where initially there are 16 players and the winners, and this is something like this happening. Like in 16 players, 8 will win. Now 8 will fight, then 4 will win, 4 will fight, 2 will win, and at the end, we will get a single winner. So you are given a tournament that contains 16 players, and the ith player has skill level of SI, and it is guaranteed that these skill levels are all distinct. That is, SI is not equals to SJ for I not equal J. That is, all skill levels are distinct. So it is known that in a match between two players, the player with the higher skill level always wins. Okay, the one who has the higher skill level will always win the tournament. So for each player I, you need to find out the maximum number of matches the player can win in the tournament if the initial pairings are made optimally. So you need to determine that if there is a player I with skill level SI, then what is the maximum number of matches he can win? Like for example, if you have something like what you are given is, you are given 16 players. Every player has a skill level, some skill level. You are given their skill level. So you are given skill level of the first player, skill level of the second player, skill level of the third player up till 16th player. Now, let's suppose I am given values something like this. Let's suppose there are only 4 players and I am given values something like this. 1, 2, 3, 4. So can anyone say me if this was the case, how many matches would 3 win the most? Like what is the maximum number of matches 3 win? So if you just try to organize it, so would you ever do something like this, that let me do 3 will fight with 4. In the first round, 3 will fight with 4 and 1 will fight with 2. Would I ever do this? Because what I want 3 to win the maximum number of matches. So would I ever do this in the starting, that in round 1, I would want 3 to fight with 4 and 1 to fight with 2? No. So what I would do? I would tell 3 that, okay, fight with 1 because you will win this match. And I will say 2 fight with 4. Now winner of this match is 3, winner of this match is 4, and now 3 can't win. So in this case, I will say the maximum number of matches 3 can win is 1. Similarly, maximum number of matches 2 can win will also be 1. Maximum number of matches 1 can win will be 0. And maximum number of matches 4 can win is 2. Is this thing clear? That if I was given something like this, a 4-player game, and I was given some input something like this, the skill levels were something like this. So my output would have been 0, 1, 1, 2. Anyone having any doubt till here? Just let me know. Understanding the question. Anyone kindly write down in the chat if any doubt persists. Okay, so no doubt. Repeat once again. Okay. So what I tell is that you are given skill level of every player. Skill level of player 1 is 1, skill level of player 2 is 2, skill level of player 3 is 3, and skill level of player 4 is 4. Now in the question, what they want that, okay, if I prefer that one win maximum number of matches, so what is the maximum number of matches one can win? So just try to think with whom you will with whom you will want one to play in the first round. Whichever player one plays with, can one win the game? The one who are having the doubt, kindly answer that if whichever player one plays with, can one win the game? No, right? So I can clearly say that one cannot win even a single match. So the maximum number of matches one can win is 0. Similarly, when I come to 2, so I want that what is the maximum number of matches 2 can win. So with which player I would want 2 to play? Would I in the first round? In the first round, if I want 2 to play with 3, then 2 will lose immediately and it will not win any number of matches. Similarly, if I play 2 with 4, again 2 will not win any number of matches. But if I do something like this, that 2 plays with 1, 4 plays with 3. If I do something like this, so in this case, 2 will be able to win a match. So when it will play with 1, so it will win the game. Now the winner of this game will be 4, and now 2 can't win the match any more matches. So I can say the maximum number of matches 2 can win is 1. Similarly, for 3 it is 1, and for 4 it is 2. So optimal case means that, see, we for every player I, we are optimally deciding, isn't it? That what is the maximum number of matches that particular player I can win. Because if I would have done something like this, that two plays with 3, then this case is not optimal, because my aim as of now is that maximum number of matches should be won by 2. So in that case, this case is not optimal. The case which is optimal, if I am aiming that 2 wins maximum number of matches, is when 2 plays with 1. Is this thing clear now? Any doubt till here? No. Okay. So now in the question you are given 16, you are given that there are 16 players, and for every player I, you need to tell that what is the maximum number of matches that player I can win. So this question entirely is of case work. Okay. If you simply try doing things, if I let's suppose tell you that there is a player I, and there are 5 players, 1, 2, 3, 4, 5. There are 5 players that have a skill level lesser than I. Okay, there are 5 players that have a skill level lesser than I. So how would I just find out that what is the maximum number of matches I can win? So first of all, in the first round, what I would do is, in the first round, if I talk of first round, so I would want I to play with 5. Okay, I would want I to play with 5. Now what I know, that in the second round, I know that I will win in this particular round, since all these 5 players have the skill level lesser than I. So I will win in the first round. Okay. So for I, count equals to 1. That is, it has already won one match. Now, if I talk of the remaining players, 1, 2, 3, and 4. So if you observe one thing, if I want I to win in the second round, if I want I to win in the second round, what I would want? I would want that, okay, this I should play, this I should play with someone in this 4 players. If it is able to do so, then only I can say na, that I will win in second round. So if I do something like this, let's suppose this I is player 6, and I have rest remaining players at down. And if I do something like this, that player 1 plays with player 7, if I do something like this, so who will win that game? Player 7 will win that game. So in that case, would I want to do that? Because what I want in the second round, some players from these 4 come. So if I do something like this, 1 play with 7, 2 plays with 8, 3 plays with 9, and 4 plays with 10. If I do something like this, so in the second round, I would get all the players that have a skill level greater than I, and I would not be able to win any more matches. So the best optimal case would be when I do something like this, that 1 and 2 plays between themselves, and 3 and 4 plays between themselves. So in this case, 2 will win. In this case, 4 will win. And now I would be able to play with 4 and go in the next round. So number of matches that I will win becomes 2, and from here I wins. And now see, for player 2, you have to choose someone who have a skill level greater than I in the second round. So from the third round onwards, you will not get any player that have a skill level lesser than I. So I can say if there are 5 players lesser than I, the answer would be 2. Similarly, you can work this for every I. You can work this for every I from 1 to 15. These are very less numbers. You can work this for every I, and you can observe that there is something, you will get something like this, that if number of players, if I just count the number of players, let count stores the number of players lesser than skill level of I. If I store count something like this, for every ith player, I store that there are count number of players that have the skill level lesser than I. So if count is equals to 0, this means that I can't win any match, my output will be 0. Else if count is lesser than 3, else if count is lesser than 3, my answer would be 1. Else if count is lesser than 7, my answer will be 2. And count lesser than 13, I had some values. So yeah, count lesser than 3, the answer would be 1. Count lesser than 7, the answer would be 2. Count lesser than 15, the answer would be 3. Else the answer would be 4. So this is something that you will observe. You can work it for every player, and once you do this, you will observe that this is happening. So now I am allowing you all to unmute. Just tell me if there is any doubt. Yeah. Any doubt, guys? You are allowed to unmute. Kindly raise if any doubt persists. Is it clear for everyone? Yeah, great. So the code is like pretty much. Wait a minute. So yeah, the code is like pretty much clear that you first of all take the inputs of all the 16 numbers, and then you go to each and every number. For every number, first of all, you initialize of your count to 0. Now just traverse over this vector and just if it is less than v of I, simply increment your count. That is, count basically stores the number of numbers that are lesser than this particular number I. So now if count is equals to 0, your answer will be 0. If count lesser than 3, answer will be 1. Count lesser than 7, answer will be 2. Count lesser than 15, answer will be 3. Else 4. And once you are done with this for every number, just print a new line. Can we use recursion? Yeah, there can be multiple approaches. This is something that I thought of during the contest. So I also need to think of if there are any other method to solve this. Like there can be multiple methods. Like this is how I worked out it during the contest. Okay. Yeah. So any doubt in this approach? Okay. So should we move on to the next question? Wait a minute.
Excuse me, sir.
Yes.
So I just want to know how many questions will be discussed.
Four,
Can you
four,
please?
four.
Okay.
Any other doubt?
Excuse
Yes.
me, sir.
Yes.
It is not mandatory to print according to the index?
It is. It is mandatory. That's why I am going on in the order. I am going on in order, and then I am looking for every I, what is the number of numbers lesser than that particular number I, and then according to that I am printing the answer.
Okay. Okay, thank you.
Okay. Any other doubt? Okay, so I am moving on to the next question. So the next question was permutation. Wait a minute. So the next question was permutation construction. So you are given an integer n. You need to find a permutation p of the integers 1 to n such that pi is greater than equals to pi plus 1 minus pi minus 1 square holds for every index I from 2 to n minus 1. Okay. You are given number of test cases and integer n. Okay. So what is the question? Question is that you are given an integer n. Let's suppose n equals to 5. So you need to print a permutation of n. Now, what do we mean by permutation of any number n? Permutation means that we print all the numbers from 1 to n. We form an array of numbers 1 to n, and every number will come once. Like 1, 2, 3, 4, 5 is a permutation of length 5. Similarly, 2, 1, 3, 4, 5 is also a permutation. But this is not a permutation. 2, 1, 3, 4, 4. Any number should not come twice. This is not allowed. 2, 1, 3, 4, 6. This is also not allowed. The numbers should be in the range from 1 to n. So basically, if I talk of permutation of length n, it is basically numbers from 1 to n come once, exactly once in the array. So this is what we mean by permutation of length n. If anyone was not aware of that, it's a very common thing that is used while solving the questions. Like many a times you need to print a permutation. So just know the permutation of length n is something like this, that every number is coming exactly once and exactly once. Okay. So now in the question, what they want? They want you to print the permutation of length, permutation of n, but there is a constraint. It's not like you are directly printing the permutation. So the constraint is that you have something like this, that let's suppose I have n equals to 5. So I will first of all fill the first number, second number, third number, fourth number, fifth number. So now the constraint is that P2, the second number, must be greater than equals to P3 minus P1 square. That is, the P2 is greater than equals to square of the difference of the adjacent numbers. Similarly, it must hold for P3 as well. P3 must be greater than equals to P4 minus P2 square. Similarly, it must hold for P4 as well. P4 must be greater than equals to P5 minus P3 square. So every number that has two adjacent elements in it, so this condition should hold. For every number I, Pi must be greater than equals to Pi minus 1 minus Pi minus Pi plus 1 square for every I from 2 to n minus 1. So this condition must hold in your permutation. So you need to print any such valid permutation. This is the question for you. Is the question clear? Anyone having any doubt in the question, kindly write down in the chat. Anyone having any doubt in question? No. Okay. So how to do this? So the first thing that came to my mind was that what I want, that okay, P2 must be greater than equals to P3 minus P1 square. And what I know, one thing that I am very much clear with is that all the numbers Pi that I am printing in the permutation is greater than equals to 1. This is something that I already know, isn't it? Do anyone have any doubt that every number in the permutation is greater than equals to 1? Since I am printing numbers from 1 to n, so every number will be definitely greater than equals to 1. So if I can do something like this, that P3 minus P1 becomes 1, then I will be good to go, isn't it? If I am able to do something like this, that P3 minus P1 becomes equals to 1, then I will be good to go, because the left hand side will always be greater than equals to 1. And if P3 minus P1 or P4 minus P2 or P5 minus P3 becomes 1, in that case, the right hand side will always be 1. So left hand side will always be greater than equals to the right hand side. And it is possible, Vishrad. It is not that it is not possible. See, then I thought of something like this. I took example with n equals to 6. I am just explaining the way I thought during the contest so that it helps you all. So what I did is, I did was that I know that there are two possible parities of n. N can either be even or n can either be odd. Then first of all, I took n as 6. So I have 6 numbers, 1, 2, 3, 4, 5, 6. So what I did was, I wanted that, okay, if you look up to the slide, what I want that the numbers Like P1 and P3 should have an absolute difference of 1. P3 and P5 should have an absolute difference of 1. P2 and P4 should have absolute difference of 1. This is something that I want. So what I decided is that, okay, I will be forming 6 numbers. So I will have P1, P2, P3, P4, P5, P6. So assigned P1 as 1. So I want P1 and P3 to have absolute difference of 1. So P3 should be 2. I don't have any other option. Similarly, I want P3 and P5 should have the absolute difference as 1. So P5 should be 3, isn't it? Now, again for this as well, I want P2 and P4 should have the absolute difference of 1. So let's start with, let's suppose 6. Then P4 should be 5, P6 should be 4. So it is possible if you observe. If you observe, then it is possible. Similarly, I sorted out the case for n equals to 5 as well, because I checked for every type of numbers, even numbers and odd numbers. If it is possible, then possible. So P1, P2, P3, P4, P5, and I have 5 numbers to fill. That is 1, 2, 3, 4, 5. So first of all, this is 1. So this must be 2. This must be 3. So over here started with 5. If this is 5, this must be 4. And yeah, we are left out with 4 only. So I observed that yes, okay, we are able to fill a permutation something like this. So this is how I solved during the contest. Like there can be this permutation also, 1, 2, 3, 4, 5. This is also allowed. It exactly depends on you how you want to fill it. It completely depends on you. But yeah, this is one possible answer of the permutation. This is what I thought of during the contest, and this will work. Because from where I got the intuition was, okay, if I am able to do this thing 1, the right hand side 1, so left hand side is always greater than equals to 1. So this is how I thought it. Anyone having any doubt? I am allowing you all to unmute. Kindly let me know. Yes, anyone having any doubt? Okay, so I am explaining the code. Wait a minute. Again explain. Okay. Are you able to understand this part, that what we actually want? Ajit, this part is clear, right? What we actually want, or you want me to? Okay. If this part is clear, so what I thought is that left hand side is always greater than equals to 1. Are you clear with that part? P2, P3, P4, they will always be greater than equals to 1, isn't it? Since we are filling numbers from 1 to n, they will always be greater than equals to 1. So what I thought is, if I am able to make this value, this difference square equals to 1, in that case, I can always satisfy this condition and form the permutation. So to make this as 1, what I decided is, if this complete value has answer as 1. So what does this mean? This means that P1 and P3 are consecutive elements, isn't it? So I sorted out for n equals to 6 that, okay, I have to fill 6 elements. This and this element should be consecutive. Similarly, this element and this element should be consecutive. If you observe, P1 and P3 should be consecutive, P3 and P5 should be consecutive. So I filled P1 as 1, P3 as 2, P5 as 3. Now again, I want P2 and P4 to be consecutive and P4 and P6 to be consecutive. So started filling P2 with 6, P4 then should be 5, and P6 should be 4. And yeah, we are also left out filling 4 only. So we will just fill 4 and we are able to form the permutation. So this is how thought of, like, sorted out for n equals to even, sorted out for n equals to odd. And since in both the cases I was able to fill numbers something like this, such that P1, P3, P5 are all adjacent elements and P2, P4 are all adjacent elements. So I filled it something like this. Is it clear now? Yeah. So looking to the code implementation exactly depends on you, how you want to implement it. What I did is that, what I observed is that I will start with I equals to 1, j equals to n. So n is basically 5 over there. I have to fill 5 elements. So I started j with n. So I am filling first of all I and then j. Then incrementing I, decrementing j. So I, j. Then again I, and I am doing this till value of I is less than equals to j. So you can observe I was initially 1, j was 5. So printed 1 and 5, incremented I, decremented j. So again printed I and j, incremented I, decremented j. Again printed I, incremented I, and once I increment I, j becomes j becomes lesser than I, isn't it? So I will not print anything and I will just return from it. So this is what I did. Initialize my I to 1, j to n, while I is less than equals to j. First of all, printing I, incrementing I, and if j is greater than equals to I, printing j, decrementing j, and at the end, a new line. Implementation completely depends on you, how you want to do it. This is how I did it. Is it clear now? Should I move on to the next question? Okay. So this is the next question. Let me go through the question. The name of the question is bouncing ball. So it's not a tough question. It's actually a easy question. The requirement or the prerequisite, what I would say for this question is prefix sum, something like that. If you know that, then this question becomes very easy. So the name of the question is bouncing ball. You are given an array A of length n, where each element represents either empty ground, ai equals to 0, or a wall, a positive integer indicating the height of the wall. So you are given an array A of length n, where every number is either 0 or some positive number. 0 means that there is a ground, and a positive number means that there is a wall of that. Like if let's suppose ai has value 2, so this means that you have a wall that has a height of 2. So now you can place a ball on any empty ground. Just observe, you can place a ball on an empty ground. That is, choose an index I with ai equals to 0. Okay. And push it either to the right or to the left. So you have options that you can either push it to the right or the left. Now, when the ball hits a wall, it decreases the height of the wall it hit by 1 and then bounces back in the opposite direction. So if the wall's height reaches 0, it becomes empty ground. So the ball continues to move until it goes out of bounds. So you need to determine the number of ways to place and push the ball so that all walls are destroyed. Two ways are considered different if either the starting index of the ball or the direction of push is different. So what is the question? First of all, let's understand the question. There are too many things written. Let's simplify it. So what you are given is, first of all, you are given an array A of length n. Okay. Let's suppose I consider the value of n as 5. Let's suppose the values given to me are something like this: 0, 2, 0, 3, 0. Okay, the values given to me are something like this. Now, if some value is 0, this means that this is an empty ground. That is, you don't have any wall over here. But if you have some value, this means you have a wall of height, wall of this height. So if you imagine something like this via a histogram, this is something like this. You have a 0 height, then you have a wall of 2 height, then 0, you have a wall of 3 height, and then 0, something like this. Okay. Now what you are allowed to do is, at any empty ground, what you can do, you can place a ball. So you have a very good ball, a very strong ball actually, what I would say, because when it is hitting the wall, it is decreasing the height of the wall by 1. So what you can do is, you can place this strong ball at any of the ground index, that is at any of the index where ai is equals to 0, and push the ball. So you are very strong, you are able to push this strong ball. You can push this ball either to the left or to the right. So let's suppose, and you can, and what happens is, when this ball hits the wall, the height of the wall decreases by 1. Okay. And the ball rebounds. This is something that is happening. So the question is that how many ways are present such that you can make you can destroy all the walls. That is, you can make all the values 0 of this array. And two ways are considered different in two cases. Either I am choosing some different index. That is, if I am choosing to place ball at this index, And if I choose to place ball at this index, so these two ways are different. The other thing is if I choose to place a ball at this index, but I choose to push right initially. And in the other case, I choose to place the ball at this index, but I initially choose to push the ball left. So these two cases are also considered different. So the question is, what is the total number of ways via which you can make the height of the wall as 0? So if I just explain you all via this example which I took, that what are the number of ways I can do so that the wall, all the walls are destroyed, if I try to explain by that. So just observe. If I place ball over here, so what would happen? If I place ball over here and I push it towards the left, nothing will happen, isn't it? If I place the ball over here and place it towards the left, it will just go. So nothing will happen. If I place ball over here and push it towards the right, what will happen? It will hit this particular wall. What will happen is 0, 1, 0, 3, 0. The height of this particular wall will decrease by 1. The ball will rebound back towards the left and it will fall. So nothing will happen, like all the walls are not destroyed, isn't it? So what does this infer? This means that I can't place my ball at this particular point. Because if I am doing so, either I am pushing left or I am pushing right, I am not able to destroy all the walls. The second case is when I can place ball over here. If I can place ball over here, so what will happen? There are two conditions that I can either push the ball initially towards right or left. Let me first of all push it towards right. So I am pushing right. So what will happen? First of all, 0, 2, 0, 2, 0. The height of this particular wall will decrease by 1 and ball will rebound over there. When the ball was rebounding, so the next wall was this. So it will decrease the height of this wall and ball will rebound over there. The next wall was this. So again, it will hit this wall, ball will rebound over here. Again, it will hit this wall, ball will rebound over here, and it will hit this wall, and ball will rebound over here, and ball will fall. And you can see that all the walls are destroyed. So when I was placing ball over here and pushing it towards right initially, all the walls got destroyed, and I can say, okay, I got one possible way. So now what is the other case? The other case is then when I place the ball over here. I place the ball over here, but initially I push it towards the left. So what will happen? First of all, the height of this wall will decrease. Ball will get pushed over, rebounded over here. Then height of this wall will decrease. Ball will get rebounded over here. Then height of this wall will decrease. Ball will get rebounded over here. Then height of this wall will decrease and ball will get rebounded in left direction and it will fall. So you will observe that in this case, we are left out with some wall which is not yet completely destroyed. So in this case, I will say that, okay, this is not my possible way. So till now I have got only one way. The next is I can place ball over here as well. So placing ball over here, pushing it towards the right makes no sense. Placing ball over here, pushing it towards the left will originate case something like this, that height of this wall will get reduced by 1 and ball will get rebounded towards the right and it will fall and nothing, and this will not contribute to your way since we have two walls that are not yet destroyed. So I can say that looking at this particular example, my total answer is 1. The total number of ways I can destroy the wall is 1. Now, is the question clear? What the question actually wants? If I by taking this example, was the question clear? Anyone having any doubt in the question? No. Okay. So how to solve this then? So one thing that you all would, I want you all to observe is that if I am placing a ball at some empty ground, okay, if I am, let's suppose, placing the ball over here. So what this ball will do? This ball will destroy all the walls that are present towards the left and all the walls that are present towards the right. Now let's suppose the sum of all the walls that are present towards the right is 6 and sum of all the walls that are present towards the, no, we should not place ball at midpoint. I am going to discuss that. Okay, just listen. So if I am placing the ball at some empty ground, and if I have something like this, that towards the right, the sum of all the heights is 6, and towards the left, the sum of all the height is, let's suppose, 3. And I place a ball over here. Now just try to guess, or just try to like think a bit, that would this ball be able to destroy all the walls? Because if you observe what is happening, if it is, let's suppose, going towards the right, decreasing this by 1, then going towards the right, decreasing this by 1, then going towards the right, decreasing this by 1, then going towards the left, decreasing this by 1, then going towards the right, decreasing this by 1, going towards the left, decreasing this by 1, going towards the right, decreasing this by 1, and now when it goes towards the left, he does not have any wall and it will fall. So in this case, it would not be able to uh, destroy all the walls, isn't it? So what is the case when it will be able to destroy all the walls? If I am placing a ball over here and sum of heights towards the left is, let's suppose, 6, and sum of heights towards the right is 6. Can someone say me where I can push this ball? Where I can push this ball, towards the left or towards the right, or both the ways? In both directions, right? Because if I push the ball towards the left, let's suppose I started it with left. Let me take some smaller example. Let I started it towards the left and sum of walls towards the left was 2 and sum of walls towards the right was 2. So first of all, this 2 will decrement by 1, then ball will go over there. Then this 2 will decrement by 1, then this 1 will decrement by 0, then this 1 will decrement by 0, and the things will work. Similarly, if I would have started by pushing the ball towards the right, the same case would have occurred, and I can say that both are the possible ways. But if I have something like this, that the sum of height of the walls towards the left is 3, and sum of height of the walls towards the right is 2. In this case, can someone say me that where I can push this ball, or where I can push this ball? Towards 3. I should start with 3. So this will get decremented by 2, then this by 1, then this will become 1, then this will become 1, this will become 0, then this will become 1, and now then this will become 0, and now the ball will fall and all the walls are destroyed. But if I would have started something like this, I would have started pushing the ball towards the right. So first of all, this would have been decremented. So it would have become 1, then this 2, then this 0, then this 1, and now the ball would have fallen. And we would have left out with a wall of height 1, which is not allowed. So we are able to work out with two cases that, okay, if we have a ball, if we have a ground, and the sum of heights of wall towards the left and right, if let's suppose this is x and this is y. So if x is equal to y, in that case, number of ways gets incremented by 2, because I can place the ball over here and I can push it either towards the left or right. Else if absolute value of x minus y is equals to 1, that is either something like this, 3 4 4 3 5 4, something like this. So in this case, I know that there is one way I have, and that particular way is that I will push the ball towards the one that have the greater height. But what if I have something like this, that absolute value is not 1, it is greater than 1, something like this, 6 4. So in this case, as we already discussed, it is never possible for me to destroy all the walls, isn't it? So in this case, my number of ways will just get incremented by 0. So if you understand this logic, now what you want for every index I that has the value 0, I want its sum in the prefix and I want its sum in the prefix. I want its sum in the prefix and I want its sum in the suffix. If I have that, so I would just simply observe from there. Sum of prefix is x, sum of suffix is y. So if x is y, number of ways will get incremented by 2. Else if absolute value of x minus y is 1, ways will get incremented by 1. Else ways will get incremented by 0. So this is the logic to this problem. Any doubt? I am allowing you all to unmute. Just let me know if any doubt. Any doubt, guys? Okay. So let's jump on to the code. Okay. So first of all, yeah, it is equivalent to Codeforce's diff2 B. So took the input of n, then took the input of n numbers, constructed my prefix and suffix array. So prefix of 0 is v of 0 and suffix of n minus 1 is v of n minus 1. So for int I equals to 1 I lesser than n I plus plus, prefix of I is nothing but prefix of I minus 1 plus v of I. Similarly constructed a suffix array. So starting with n minus 2 greater than equals to 0 I minus minus. Suffix of I is suffix of I plus 1 plus v of I. Now initialize my answer to 0. If suffix of 0 is 0, what does this mean? This means that sum of all the values of the array is 0. This means that all the values are ground only. This means at every position I can place a ball and push it either towards the left or either towards the right. I can anytime do it, isn't it? So in that case, what I am printing n into 2. For every possible position, for every possible index, I have two directions, either towards the left or right. So my total possible ways become n into 2. So I am printing that and returning. And if this is not the case, I am going to every index from 1 to n minus 1. Okay. I am going to every index from 1 to n minus 1. If v of I is 0, if v of I is 0, this means that this particular position in a ground. So I am just simply checking that what is the number, what is the prefix sum of this and what is the suffix sum of this index. So if prefix of I minus 1 is equal to suffix of I plus 1, this value is x and this value is y. We have x and y. So prefix of I minus 1 is x, suffix of I plus 1 is y. So if these two are equal, so I know that number of ways will get incremented by 2. Else, if they are not equal, but they have the absolute difference of 1, in that case, the number of ways will get incremented by 1. And at the end, I am printing my answer. That is the total number of ways. So yeah, again, the implementation part depends on you. Yeah, we can solve by using only prefix as well, because I can get this sum by using prefix only. But again, I say that implementation completely depends on you. But the thing is, for every index I, such that ai is equals to 0, I want to have these two sums. All the heights towards the left and all the heights towards the right. Yeah, I can do some suffixes total sum minus prefix. So which case, Vishwaraj? This case? Wait, I am allowing you to. You are allowed to unmute 0 once. Okay, this one. Okay. So this case is, let's suppose I have n as 4 and all values are 0. Okay, all values are 0. So for every position, what I can do, I can either push the ball towards the right or I can push the ball towards the left, because we don't have any walls now. All walls are of height 0. So initially, yeah. So the answer will be 2. For every position, you have 2 values. Anyone else having any doubt? Any other doubt? This logic? Yeah, it would be like this. Actually, I wrote during the contest. So I am explaining the code that I wrote during the contest. So that's why it's written. Yeah. Anyone else having any other doubt? Okay. So let's move on to the fourth question. So the name of the question is back front. So let's go through the problem statement. So for the lowercase English letter alpha, let ORD of alpha denote the order of alpha in the alphabet under the standard ordering A, B, C, Z. For example, B is said to be 2, J is said to be 10, Z is said to be 26, something like this. Now you are given a string S containing n lowercase English letters. You can perform the following two operations on it. Choose a subsequence of the string that equals to back, okay, and delete the subsequence from S. Then choose any character alpha such that ORD of alpha has at most two divisors. So when we listen to at most two divisors, what are the numbers that come to our mind? A, 1 and all prime numbers, isn't it? 1 and all prime numbers has at most two divisors. So what you can do is you can choose any subsequence back, remove it from the string S, then choose any character alpha such that ORD of alpha has at most two divisors and insert alpha at the start of S. So note that this operation reduces the length of S by 3 because you are deleting a string of length 4 and inserting a character, one character. So overall it reduces the length of the string by 3. Similarly, what you can do is you can choose a subsequence of string that equals to front, delete the subsequence from S, and choose any character alpha such that ORD of alpha has strictly more than two divisors. And you can append alpha to S. So note that this operation reduces the length of S by 4 because you are deleting a string of length 5 and inserting one character. So it overall reduces the length of string by 4. So you can perform these two operations as many times as you like and in any order. So you need to find out the minimum possible length of the final string after doing so. Okay. So like if I talk of this test case, BXABCA, BX, BXABCA, CFKCP. So what I can do is I can choose this subsequence BACK, remove it, and insert some character. I am not telling which character I am inserting. Again, I can select this BACK, again remove it, and insert one new character, and I am left out with this. So now whatever character I append over here, whatever character I select over here, I will be left out with string of length 5 and my job will be done. Okay. So 5 is the minimum length that I can construct. But if let's suppose these characters were not X and F and these characters were something like this. These characters were, let's suppose, C and K. So what I would have done is I would have inserted B and A, the new characters that I am choosing. I would have chosen them B and A. And now I would have removed this entirely and insert one new character. So I would have been left out one new character and this left out character C. So my answer would have been 2 in that case. So you can observe that what are the other values in the string? What are the other characters in the string? According to that also our new characters gets decided. So this is the question. Do anyone have any doubt in understanding the question? Okay. So let's think. Let's go to the intuition of this problem. So if you observe that, okay, once again explain. So you have this string B X A B C A C F K C K. Okay. So what you will do is you can choose any subsequence back and remove it and insert any new character at the front. So you choose, let's suppose B A C K, something like this, and insert a new character in the front. Then you again choose B A C K, insert new character at the front. So if you observe, you will be left out with two new characters, X, F, and C. Okay. So you can observe that in this case, the minimum length of the string is 5. But what I told is, like, let's suppose instead of F and C, you would have add C and K, something like this. So now if you would have decided two new characters as B and A, so now again you would have been able to find a subsequence that is equal to back, remove this subsequence, and insert one new character, and the left out character is C. So in this case, the minimum length of the string would have been 2 instead of 5. So is the question clear now? The one who was asking? Okay. So what's the intuition? The intuition to this is that, okay, if you observe to the question once again, then whenever we are inserting a new character, we have the restriction in that the new character can have at most 2 divisors. Okay. So what are the new characters that I can insert? If I just write down this A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Just write down these values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if I just circle the characters that I can add while I am removing a subsequence named back. So I can add those values that have this value have at most 2 divisors. So I can add A, B, all prime numbers and 1 because all prime numbers and 1 has at most 2 divisors. So C, E, G, K, M, Q, S, W, and yeah, these are the characters that I can add. So one critical observation in this case was that what is happening actually? We have a string. What we are doing? We are selecting some value back. We are selecting some subsequence back, removing it, and then adding a new character at the front. And the character that we are adding do not match. I repeat, the characters that I am adding do not match to any of the characters of this front. It neither matches to F, it neither matches to R, neither O, neither N, neither T. This means that my answer for front does not depend my answer from back. Like if I have character something like this, O and T, and let's suppose you say that, okay, you are removing back. Let's suppose I have something like this. You are removing 2 backs. Just add FR over here and you would also get a sequence FR, O and T. But this is not possible because whenever we are removing a subsequence called back, then whenever we are adding a new character, those new characters does not matches to any of the character of front. And the same is for front as well. Like whenever I am removing any subsequence of front, and if I let's suppose have B, A, C, something like this, if I remove this, I am adding a new character at the end, but this character does not matches to any of these characters. This character does not match to any of these characters. So I can never say that by removing front, I added a new character and this new character has helped me to reduce the string by choosing a subsequence BACK. This is something that is never possible. Are you all guys able to relate till here? Like this was one critical observation. Once you understand this, now the question will become easy. Now there is nothing left in the question. Okay. So now how to solve the question? See. So what I did is that, okay, I have to remove some back. But let's suppose I have something like this. A, C, K. So if you observe, we have a back here. We have a back here. And we have A, C, K over here. We have A, C, K over here. So what is the benefit of this ACK? The benefit of this ACK is that if we add B at the front, so this entire would be removed. Similarly, if we have something like this CK, so what will be the benefit? The benefit will be that if we add BA at the front, so we can remove this entirely. Similarly, if we have K, so what is the benefit? The benefit is if we have BAC, if we choose new characters to be B, A, and C in this order, so I can remove this as a whole. So the observation was that, okay, if you have a string something like this, B, C, A, B, A, C, K, C, A, K. Okay. If you have a string something like this, so just traverse from that. What are the following patterns you want? you either have BACK, or you have ACK, or you have CK, or you have K. If you have any of these, they are of use to you. Any other things are of no use to you. Are you able to relate this? If you have any of these strings as a subsequence, then they are of some use to you. Otherwise, any other subsequence is of no use to you if you are at a time choosing subsequence BACK and removing it. So what I did is I traveled from back. I got a K. Okay. Let's suppose the number of these are count 1. Let's suppose number of these are count 1, number of these are count 2, number of these are count 3, and number of these are count 4. Okay. If you have something like this. So I just traversed from back. You will get it that why I'm traversing from back once I traverse completely. Okay. So you get a K. So you simply increment the value of count 1. So value of count 1 becomes 1. Initially all are 0. Okay. Now I came to A. So just tell me, if I am coming to A, so what I will check is that if I have CK from before, if I tell you that you have ACK as well and you have CK as well, so which is of more importance to you? Can someone say me? Can someone say me which is of more importance to us, ACK or CK? ACK, right? Because ACK wants me only one new character to insert and the entire string will be deleted. So what I am doing is, if I am getting A, so I am just checking if I have CK from before. Since my count of CK is 0, that is the number of CKs that I have got is 0. So I will, if I don't have CK, so I would not be able to form ACK as well. How you are, I am explaining it. Once I traverse this entirely, you will get it. Okay. So once I get CK, then only it is possible for me to construct ACK, else it is not possible, isn't it? So I will just ignore this A because I don't have any CK. Now I get a C. Now the one who was having the doubt that how I am implementing the double counting, just observe. Once I get a C, so I will just check if I have K or not. If I have K, then only I would be able to form this CK, isn't it? Now, since I have a K, and I know that K is of lesser importance in comparison to CK, so I will increment the count of CK and decrement the count of K by 1. Are you able to get it? So what I did is I decremented the count of CK and incremented the count of K. So now what I have 1 CK, 0 K, 0 ACK and 0 BACK. Now I come over here. So again, I increment the count of K by 1. Now I come over here. I come to C. Now again, it is possible for me, since I have a K, it is possible for me to form CK. So I incremented the count of CK by 1 and decremented the count of K by 1. So it becomes 0. Now I get A. Once I get A, again I check, do I have CK? Yeah, I have CK. So what I will do, I know that since I have A and I also have CK before, so what I can do is I can decrement the count of CK by 1 and increment the count of ACK by 1. Okay. Now I come to B. So again, I know that back is of most importance to us. So what I do is since I have ACK, so I incremented the count of back with 1 and decremented the count of ACK with 1. So it becomes 0. Now I come to A. Now, if I get a, I will look if I have CK or not. Since I have CK, so what I would do is I will increment the count of ACK by 1, decrement the count of CK with 1. So it becomes 0. Again, I get C. So if I get C, I will check if I have K or not. I don't have any K, so this C is of no importance to us. Again, I get B. So once I get B, I will check, do I have ACK? Yeah, I have ACK. So I will increment the count of back with 2 and decrement the count of ACK with 1. So at the end, I was able to observe that I get 2 BACK, 0 ACK, 0 CK, and 0 K. When I'm telling that I am getting 0 ACK, what does this mean? This means that these are ACKs without B. That is, you have something like this. ACK is without B. These ACKs don't have B at the front. They are lonely. They don't have B at the front. So these ACKs are without B. Whereas these ACKs are with B. So they will not count in this subsequence ACK. They will count in BACK. Okay. So once you, so now you all would be able to relate why we were traversing from back. Because we want this K, KC, KCA, KCAB, something like this. So that's the reason we were traversing from back. Once you are done with this, once you are able to construct something like this, BACK, ACK, CK, and K, once you are able to construct this. So let's suppose you have BACK, count 4 number of times, ACK, count 3 number of times, CK, count 2 number of times, and K, count 1 number of times. So now what I will do is, I know that when I remove all the characters of this, all the characters of BACK, what would happen? That how many new characters I will get and how many characters will be deleted. Can anyone say me? Can anyone say me how many new characters I will get if I delete all the characters of all these BACK, that is occurring count 4 number of times? Any guesses? I am removing all BACK subsequence. How many overall characters will get reduced from the string? So every time I remove BACK, one new character gets inserted. This entirely gets deleted and one new character gets inserted. So can I say that there is an increment of +3 for every BACK? So if there are count 4 number of BACK, can I say that the number of my number of characters get reduced if I am saying it is answer? So answer will get incremented by 3 into count 4. Do everyone understand this? And can someone say me what is the number of new characters that I will get? Can I say that the number of new characters that I will get is count 4? Because these many BACK I deleted. So those many new characters I will get. Why I am keeping count of new characters? Because this will help me, because these new characters are something that I am putting. So I have full control in this. So this will help me in reducing ACK, CK, and K. So that's the reason. Okay. So I can say that number of new characters that I am putting is count 4. To everyone on the same page till now? Is everyone on the same page till now? Okay. Now, what is the next thing I will do? Okay, I am done with BACK. Now the next thing I will come is to ACK. I will tell that, okay, to remove all the characters of ACK, the only thing that I need is a new B. A new character B, and I will be done. And if I do so, what will happen is my number of, if you observe, I am taking one character. What is happening is I am removing this entirely, and then I am putting one new character. So if I am doing this, can someone say me, will there be an increment in the count of number of new characters? Will there be an increment in the count of number of new characters? No. No. Because what you are doing, you are taking one new character, you have in store 5 new characters. Let's suppose you have 5 ACK. So you took one new character. So number of new characters count get decreased by 0. Gets decreased by 1. And now you remove, once you remove this back, again the number of new characters count get increased by 1. Again, if you reduce new ACK, number of count of number of new characters get decreased by 1. And again, you are able to form BACK. And again, when you remove this BACK, again the number of count of new characters will get increased by 1. So it becomes 5. So when you are doing this, the count of new characters does not decrease, isn't it? And can someone say me what, by how much the length of the string will get reduced? If I am, let's suppose I will not be able to remove all these count 3. If I am, let's suppose, don't have any new character. If let's suppose the number of new characters, if number of new characters is equals to 0, will I be able to reduce any of this ACK? will I be able to reduce any of this ACK since I don't have any new characters? No. So if I am having the new character, let's suppose I am telling you that I am decrementing, I am reducing temp number of this ACK subsequence. So can someone say me what by how much my length of string will get reduced? By how much my length of string will get reduced? 2 into temp, right? Yeah, depends on number of ACK, but I am telling you that I am reducing temp number of ACK. So now can I say that my string will get reduced by 2 into temp? Because every time I am removing these 3 characters, I am getting an additional character, isn't it? Whenever I am removing these 3 characters, I am getting an additional character. Now don't get confused that the number of new characters is not increasing. Don't get confused by that. The number of new characters is not increasing because whenever I am choosing a character B for this completion of BACK, this B is actually a new character. So that's why when I'm telling that the number of I am getting one new character after deleting this BACK. So the new character that I am getting takes the place of this B. Because I used a new character, I got a new character. So that's why the count of new character is not increasing, but the total length of the string is getting reduced by 2 into 10 because I am deleting these 3 characters and in return I am getting 1. Okay, wait a minute. Will it be 2 into 10? Right. Okay, it's decreasing by 3 only. It will get decreased by 3 only. It will not be 2. Yeah, I told it wrong. If we have BSC, if we have ACK, so what we are doing, since during the contest, what I did is that the new character that I am taking is, I am not reducing his length. That is basically, if you understand by this, if we have some new characters, so what I am doing, I am choosing that new character BSCK. So in total, from my string, I took 4 characters and I will get only 1 character in return. So it will reduce my length of string by 3, isn't it? So this will be 3 into 10. Yeah. Sorry for the confusion. Anyone have any doubt till now? Anyone have any doubt till now? Did anyone got confused by this? Don't get confused. We have ACK and we have some new characters, and this new character is actually present in the string. I am assuming that it is present in the string. So what I am doing is I am taking this new character, placing it over here. So this actually forms a string of length 4, and in return I will get 1 character. So it actually decreases the length of the string by 3. Every time we are removing back right, so it will always decrease by 3. Back, what do you mean by back right? Yeah, every time we are time we will get a decrease of 3. Yes. Since every time we are reducing back, so we will every time get a decrease of 3. You are correct. Can you please explain from the previous slide? This slide, which one you didn't understand? Can you tell me? The one who was asking. Wait, let me allow you to mute. Yeah, you can unmute. Kindly say me where you didn't understand over here. I can't explain the entire thing briefly actually. So what we are doing is we are getting the number of counts of back, ACK, CK, and K. And every time what we are doing is, first of all, we are removing all the back. So I know the number of characters that will get reduced from the string is 3 because we are removing 4 characters and getting 1 in return. So number of characters will get in, number of reduced characters get incremented by 3 into count 4, and number of new characters becomes count 4. So now again for ACK, I know that since I am inserting 1 character, so and this character is actually a new character, and after removing this, I will get a new character. So actually what is happening is I am taking a new character, getting a new character. So count of new character will not change, but the length, but if I am, let's suppose, removing temp number of these ACK, so temp number of these ACK, then the length of the string will get reduced by 3 into 10, isn't it? So I explained it, Siddhant, in brief. Is it clear? Okay. So now again, now if I am done with ACK, so let's suppose now I am removing CK. Let's suppose I am removing CK. So can I say that if I am removing CK, so what I am doing? What I am doing? If let's suppose I have 4 new characters, I have 4 new characters. So can I say that what will happen is that I will use these new characters, I will place it over here and remove this as a whole. Again, if I let's suppose have one more CK, I will use these two characters, place it over here, remove this as a whole. Let's suppose I have more 2 CKs. Will I be able to do the operation again? I will be, because I will get a new character from here. I will get a new character from here. But this is something that you don't need to be worried of. This is something that I handled it in the loop. I have ran one while loop. I will show you in the code. Like that is not actually my code, but the code that I have in that, there is a loop that is handling these conditions. So for now, you will tell that you can, if I let's suppose have 3 CKs also, and I have only 4 new characters, so you will say that okay, I will be able to fulfill the need of only 2 CKs. As of now, you will tell only that. Rest, when we will come to this again, when we will come to the CK again, we will see that okay, we can fulfill these as well. You will get to know once I show you all the code. Okay, but just keep in mind that yeah, we can remove one CK more from by getting these characters. And again, when we have K as well, let's suppose we have K as well. So again, the same thing we can do for this as well. We can choose 3 new characters and do it. And let's suppose you have now at the end, let's suppose you have 5 new characters left. So what you can do, you can choose 4 of these new characters, construct back, and from here you will get 1 more new character. And this is 1 new character. So in total, you will get 2 new characters. Okay. So once you keep on doing this till you are able to do this, so do that and just at the end find out that how many total number of characters you are reducing and how many total number of new characters you are left with. Okay. So if you are doing that, so then you will be good to go. Same logic persists for front as well. So I am not going to explain the logic for front, but the same logic, exactly the same logic. The only difference is that in the back, what we decided, we are going to take K, we are going to take CK, we are going to take number of ACK, and we are going to take number of BACK. So for that, we traverse from left to right. In front, the same logic, by same logic, we say that we want to take number of F, number of FR, number of FRO, number of FRON, and number of FRONT. So since we want this, so we should traverse from left to right. Okay. So exactly the logic remains same, but in back you need to traverse from right to left, and in front you need to traverse from left to right and store these things. And after that, the code remains exactly the same. Whatever you are doing for back, the same thing you have to repeat for this front as well. So let me show you all the code. So first of all, took the input of n, then string s. Now, since we know that for constructing back, we need to traverse from right to left. So there is a string taking this s, copying the value of s in this another string s2 and reversing this string s2. Okay. Now initialize my count of a to 0, b to 0, c to 0, d to 0. There we were having 4 variables for storing k, ck, ack, and back. So it is exactly the same. For k we have a, for similarly for ck we have b, for ack we have c, and for back we have d. So just traversing over the string, if we are getting a character k, so in this case we are simply incrementing a. If we are getting c, then we are checking, do we have k? So if the value of a is greater than 0, this means that we have a. This means that we have character k. So decrementing the count of character k, incrementing the count of ck. And similarly for the ck, ack, and ack and back. Okay. Once you are done with this, so you know that you have d number of back, c number of ack, b number of ck, and a number of k. So your answer, the number of characters that you will be able to reduce is d into 3, because for back you are removing every back, and for every back you get a new character. So in net you are able to reduce, for every back you are able to reduce 3 characters. So if you have d number of back, the total number of characters you were able to reduce is d into 3. And initializing my count to d, this count basically stores the number of new characters that I have. Now while I have the number of new characters greater than 0, so if the number of ack are greater than 0, so what I know is that if I have number of ack as greater than 0, so whatever number of ack I have, I will be able to reduce all of them. Okay. Whatever number of ack I have, I will be able to reduce all of them. My count of new characters will not change, but the count of ack will become 0. So to my answer, c into 3 got multiplied, because if I am removing ack, this means I am removing back as a whole, and I am getting a new character. So for every c, I am able to reduce 3 characters. So in total, to my answer, we will add c into 3. Everyone on the same page till now? Anyone having any doubt till now? Kindly let me know. Okay. Else?
Sir,
Yes.
I have a doubt, sir.
Yes.
Sir, how like we have all the ACKs will be completely gone? Like,
Yeah, if we have a new character, so what will happen? We have some ACK. We will take this new character as B, remove this BACK, and in return, again, we will get a new character. So again, if we have an ACK,
yes,
so
yes, I
again, we
have.
will see. Okay. Okay. Great. Anyone else? Any doubt? Okay. So now let's suppose we don't have ACK. We have CKs. So the count of CKs are stored in B. So now for removing CK, what we know that the minimum count of new characters should be 2, isn't it? If I am telling you that I want to remove CKs, so the minimum count of new characters should be 2. So if number of CKs are, if some CKs are there and count is greater than equals to 2, in that case, can someone say me that how many numbers of CK I will be able to remove? So the number of CKs that I will able to remove is minimum of B into 2, comma count. Because for every B, how many number of new characters we need? 2. For every B, we need 2 new characters. Kindly mute, please.
Okay.
For every B, we will be able to, for every B, we need 2 new characters. So the number of B's that we will be able to reduce is minimum of B into 2, comma count. So once I understand that, so what I know now is for every B I am removing, that is for every CK I am removing, the number of new characters count get decremented by 2. So if I say that I am removing temp number of CKs, so can I say that my number of new characters count will get decremented by temp by 2? And if I am removing temp number of CKs, so can I say that my number of characters that actually gets reduced from the string is temp by 2 multiplied by 3, isn't it? It is temp by 2 multiplied by 3. And my number of CKs, that is number of B's, will get reduced by B minus equals temp by 2. Once you understand this for CK, once you understand this for ACK, sorry. Once you understand this for ACK, this is actually for ACK. Once you understand this for ACK, so the same will be for, sorry, what I'm saying. Once you understand this for CK, so the same will be for K as well. And once the same thing. And else, if you don't have ACK as well, you don't have CK as well, you don't have K as well. So now what you know, that if you have, let's suppose 5 new characters, so you will take 4 as a whole, place BACK over here, remove this and insert one new character. This is something that you will do. So did the same thing over here. My answer will get incremented by what is the number of new characters I have divided by 4. So these are the number of BACK I can form, and for every BACK that I can form, I will be able to, for every BACK that I will form, I will be able to reduce the number of the string length by 3. So total number of BACK that I will be able to form multiplied by 3. And my count will get decremented by the number of new characters count will get decremented by the number of BACKs that I will be able to form multiplied by 3. Because all characters of BACK are new characters, isn't it? So I took 4 new characters and in return I am getting 1. So yeah, count will get decremented by 4. And if count is lesser than 4, then I will simply break from it. Because I know that I will not be able to form anymore. I will not be able to reduce the string anymore. And the same thing for FRONT as well. The same thing. So first of all, storing the count of F in A2, FR in B2, FRO in C2, FRON in D2, and FRONT in E2. And then again, the same thing. The code is exactly the same. And once you're done with this, so you know that answer number of characters you were able to reduce. So if s dot size is the total length of the string, so your answer will be s dot size minus answer. So this is actually the code for this question. It would take some time for you to understand, but once you do so, try to run it by yourself, and then you would be good to go. Just wait a minute.